We're going to talk about two ideas in this video. The first idea of which is what's called the domain of a function. Again, domain of a function usually means what x values have I plugged into a function. However, for functions, we also sometimes have limitations. We're only allowed to plug in certain x values. There's limitations with our numbers. Two major things where we have limitations are square roots. Remember that to get real answers back, right? And again, domain, what x values can we plug in that will get us back real answers? So again, when we think about square roots, I don't want to plug in negative numbers because those won't get us back real solutions. Also, we could talk about division, such as this third example down here, or the fourth one. When we're talking about division, remember, we never want to divide by 0. So two major things to watch out for, at least for now, square roots and division. So now you'll notice in the first function, we really don't have either of those problems. No matter what real number I plug in for x, we can always square a number, we can always multiply numbers, we can always subtract or add real numbers. So really, when I'm looking at that first function, I'm thinking our domain is all real numbers. So that'd be one way to write that, all real numbers, right? And again, let's just describe that. That's all real numbers. Again, a great way is that R, capital R, with sort of a double bar on it. It's a great way to represent all real numbers. Now, this second function, let's just call it g of x. I'm going to change that to a g of x there. So we're talking about function g of x. Now we've got a square root there. And remember, we said we're not allowed to plug in negative numbers under square roots and get real answers back. So what I need to guarantee myself is what's written underneath there. So that 4 minus x, I need to guarantee that that stays greater than 0. So let's just solve that real quick. Negative x would be greater than negative 4 if I subtract 4 to the other side. And if we divide by negative 1, right, we quickly find out that x needs to be less than, remember if I divide by a negative, I flip that sign. Negative 4 over negative 4 would be 4, and we have a domain that x is less than 4. Along those same lines, again, let's call this one h of x. We'll change the names a little bit there just so we can specify. H of x, well, now we don't have a square root, but we do have some division. So I need to guarantee myself I'm not dividing, again, by 0. So let's quickly do a little algebra. X minus 5 can't be equal to 0, which means x alone, if I add 5 to the other side, can't equal 5. Now, what you want to remember is domain is what numbers can we be. So I want to say that all real numbers are fine as long as x is not 5. I want to rule out that 5. Right? I want to rule that out. Again, what numbers can I be, though? All real numbers other than 5. Now, this last option, again, let's just call it m of x real quick. You're down at the bottom, m of x. We've got to be careful. We've got a square root on the top, but we also have a couple options on the bottom. The first thing I'm going to realize is if it says x plus 6, if I try to plug in negative 6 right now, that's going to end up equal to 0. So the first thing I want to realize, x can't be negative 6. X plus 1 on the bottom, kind of the same idea. If I multiply these two things on the bottom and one of them is 0, I've got a problem. So I got to make sure that x isn't negative 1 either, because negative 1 would cause this whole statement to be 0, times x plus 6 is going to be 0. Therefore, I don't want to be negative 1. And then finally, we need to look at it and say, well, wait a minute, square root. X plus 2, remember, needs to be greater than 0. Got to be a positive number, which means x is greater than negative 2. Well, looking at that all together, if x has to be greater than negative 2, x couldn't be negative 6 anyways, so I'm really not worried about that statement. Okay? If x is greater than negative 2, though, but can't be negative 1, we would have to be a little bit careful. We're going to have to say x is greater than negative 2 such that x can't be negative 1. So again, that would sort of be our good domain there. Now that gets a little bit messy to write. So sometimes when we write domains, we want to write them using what's called interval notation. So let's get a quick intro to interval notation, then we'll come back and we'll fix each one of these up. Interval notation is just another way to write, rather than inequalities, how to write sort of a span of numbers, an interval of numbers. Parentheses sort of represent not equal to, right? Or not or equal to. The square brackets over here in red would represent or equal to. So if we were looking at something like y is greater than or equal to 4, what we would want to say is, well, we're starting at 4. If I think about that interval on a number line, I want 4, right, or equal to, and I want everything above it. So we're going to include 4, and we're going to travel essentially infinitely to the right, up to infinity. But I want to include 4, or equal to. So I'm going to use that solid bracket like we have up here at the right. Now, because infinity is not a real number and we can never really reach it, technically we always go with not or equal to when it comes to infinity. So I'm going to do a soft bracket there. I'm going to do that parentheses. In that same way, again, it's a great way to think about these as intervals. If I start at 0, x is less than 0. I don't want to include x, but I want to go less than that. Well, if 0 is as high as we want to go, but we're okay with going all the way down to negative infinity, again, I can't include infinity, it's not real. And I don't want to touch 0. We don't want to say or equal to. So again, we're going to say soft bracket there. That would be another way of representing the statement x is less than 0. Down here at the bottom, well, what if we want to be in between two numbers? Well, if negative 3 is as low as we want to go, again, thinking about those two spots, negative 3 down here is as low as we want to go, but not included. Note soft bracket. All the way up to 12 included, and we want to be in between. Well, let's go up to 12 then, and we can say hard bracket, or basically or equal to there. Let's travel back to our answers from the previous screen, and let's think about how would we write these using interval notation. First of all real numbers basically is every number from negative infinity to infinity. And again, we always want to do soft brackets. If x is less than 4, again, we're going to top out at 4. We're going to bottom out at negative infinity. Soft bracket there, no or equal to, so therefore soft bracket here as well. Now wait a minute, I want to rethink that problem a little bit though. If I plugged in 4, the square root of 0 is 0, right? 4 minus 4 would be 0. That's a real number. I better fix that. X is less than or equal to 4, I think would be an okay statement to make. Therefore, we want to make sure that our bracket over here includes that 4. We'll fix that up real quick. Again, a very big difference there whether we include 4 or don't include 4. So again, that hard bracket gets the point across. Then we want all real numbers, not 5. Well, think about it. I want to go from negative infinity to infinity, but I don't want to include 5. So when I get to 5, it can't be included. Or when I started from 5, it couldn't be included. And then what we'll do is we'll say union with. I want to go from negative infinity up to 5, union, combined with, 5 to infinity, just not including 5. Some books, instead of saying union, you can really just put a comma or say and. Again, I think it's a great way to put union on there and just kind of represent. We want everything in both intervals, just not the 5. Note the soft brackets. And we can take advantage of that for this bottom one as well. If we want x is greater than negative 2, then we're going to start at negative 2. We're going to travel up. We don't want to include negative 1, though. We're going to travel up to negative 1. And again, we're not going to include either one of those. Oh, I made the same mistake there, though. We're okay with 0. So actually, let's do a hard bracket on that negative 2. Up to negative 1, not included. Again, negative 2 would just make the top 0, and that's perfectly okay. We can divide 0 by a number. We just can't divide 0 on the bottom, right? Which is why we didn't want negative 6, we didn't want negative 1. Again, we're going to restart at negative 1, because we still need to represent everything greater than negative 2 all the way up to infinity, just avoiding, again, that negative 1. So that would be a good interval notation. Again, if you have questions on domain or interval notation, make sure you talk to your teacher. Otherwise, have a great day.